So alright guys, today's video is going to be relatively short. I want to mainly talk about the single Npn transistor oscillator from a few videos ago. With that said, some of you guys were probably disappointed when you went and put this thing together and realized it didn't oscillate like you wanted it to. In fact, if you built it with a modern battery and a lower current LED, this thing would just stay on just like any other Joule Thief circuit. This thing won't oscillate unless you have a high resistant battery and a high current LED. In fact, this is the same circuit I used in my diorama project, which stays on constantly 24/7 365. This circuit constantly pulls 0.097 microamps, meaning off a single D-cell battery, this thing should easily run 10 plus years. I'm expecting it to go 15 to 16 years, personally. But with that said, it doesn't oscillate as in go on and off, it's just constantly oscillating as in making it look like it stays on. To actually fix this, all you need to do is add two components to the circuit, one being a capacitor and a bleed resistor. Essentially, you add the capacitor to the negative end of your LED, then put that to ground and put your bleed resistor across the capacitor. Now, depending on your capacitor and bleed resistor values, you can actually affect the pulse timing of the whole circuit. On my particular setup, on a fresh AA battery, it will blink anywhere from 2.5 seconds to 2 seconds. However, if I insert a dead battery at 0.8 of a volt, damn near the transition point of the Npn transistor itself, it will actually self-oscillate at about 3 seconds. So the timing does vary, so if you want to build a pulse motor or pendulum off of this circuit, just know that over time as the voltage drops, the timings will be thrown off. So you may want to include a sensing coil just to adjust for that, for the drift over time. However, we will be building a motor out of this circuit someday in the future, so expect me to talk about this at least one more time. In fact, in the B-roll here, you can see one of my new pulse motor designs. It's effectively just a balanced spinner, and you can replace the top load with whatever you want. Eventually, I want to put a globe there, but you get the point. Other than that, I also put this circuit in a glass bottle with a galvanic cell. This galvanic cell powered the original circuit for about 19 weeks, so I'm expecting nearly triple the runtime off of this just based off the current estimates that I've pulled, and I'm expecting it to easily run for at least a year to 2 years. So that's pretty cool for what is essentially just some pennies put into some dirt mixed with some salt. Now, if you actually want to get into the math for how well I have improved the circuit compared to the last one, this thing draws 0.003 microamps, 0.011 microamps, and up to 0.056 microamps, never more than that. If we were to sum up these estimates, I have done that. I've also had AI do it. The AI estimate set off a single AA battery, this thing could run for 12,000 years. I personally don't believe that at all. My runtime estimate for an AA cell with this particular circuit would be around 10 years, and it would probably start leaking around 6 to 7, maybe 8 years in. And when it came to the D cell, just for fun, I ran those numbers through and got an estimate as well through the AI, and it said 96,000 years, so I'm really doubting these estimates that this thing came up with. My guess is around 70 to 50 years of runtime, assuming if the battery didn't fail before then, which most likely it would. With that said, feel free to correct the math if you can in the comments section. I would like to hear what you would think this would run at personally. However, with that said, you may be wondering why I didn't put this circuit in the diorama build. Well, yes, I could have had it blink on and off. It's something I could have done since the start of that project. But I am aware that the batteries won't nearly last that long, and I'm limited by the fact of the battery more than anything. So I'd rather it be just constantly lit and fail naturally due to the battery age and be blinking than, not having any idea as to when this thing will shut off. I'd rather have it constant current driven than not at all. It was also easier for me to calculate the runtime as you saw in that video. This video, it was really hard for me to calculate any runtime for this new circuit. But yeah, with that said, I built two of these little circuits. I have one in a bottle, one in a little globe. One's more sealed than the other, and I'm assuming the 19-week runtime that I had previously off the old circuit with this new one will easily extend it to a year or 2 years. We will see, and if it does, we may actually dive deeper into this and make a even better galvanic battery just to see how much further we can push this. But for the time being, I'm going to leave today's video off here. I hope it was rather insightful, maybe inspired you to use this circuit in one of your designs. But for the time being, I'm going to leave this off here now. DTPK signing off. Peace. I don't think those are ever going to be a failure point when it comes to this little diorama that I put together. Reclaimed screws. I'm using reclaimed screws from my original Xbox hard drive holder. It's